So you've just started out with Kubernetes and you're new and you're learning about all these YAML files that you have to maintain. If you've been learning about Kubernetes and how to run applications on top of Kubernetes, you've probably come across a tool called Helm. In Kubernetes, we describe everything we do with YAML files. These YAML files represent objects such as deployments, pods, services, config maps, secrets, and more. Well, the beauty about Kubernetes is that it's declarative. What does declarative mean? Declarative is rather than writing scripts, we tell Kubernetes exactly what we want, and Kubernetes makes it happen. If an application goes down or the server underneath goes down, Kubernetes scheduler will move that application to another machine. It does this by taking the desired state of what we want and monitors the actual state, and it makes sure that the desired state matches the actual state. The desired state is defined by these YAML files, and that's what makes these YAML files important. But managing all these YAML files can sometimes become a little complicated. To demonstrate this, a system in Kubernetes can have multiple YAML files. Now, if we take a look at my GitHub repo, for example, and we go into the Kubernetes folder, we can see I have a deployment folder with a deployment.yaml. This describes to Kubernetes how to deploy my application. We tell it how many replicas we want, what container image we want to deploy, the ports to expose, and the resource limits. But my application needs more than that. So we also have a secrets folder with a secret.yaml where we have a secret definition of a secret that my application might need. We also have a config map. So we take a look at the config map folder. There's a config map YAML. So my application also needs some form of configuration. Now my application needs to be exposed to other services. So I have a services folder with a service.yaml that tells Kubernetes how to expose my application. And here we describe that we want a load balancer and we want to expose port 80. Now there's more than that. Maybe I need some storage, so I have a persistent volume folder with a persistent volume describing some storage that my application might need. And there are many other types of Kubernetes YAML files as well, so it doesn't end here. So it's important to notice that all these YAML files make up my application and its infrastructure. And it's important to notice here that it's not reusable. Now, if I want to build another application to reuse this YAML, I would have to copy paste all of these files and then change what's needed. And as I build more applications, I may end up with a lot of YAML files and a lot of duplication. And over time, these YAML files may become hard to manage, and this is where Helm comes in. Helm is a package manager for Kubernetes. It allows us to bring all of these YAML files together in what's called a chart. A chart can have a name, a description, and a version. A chart groups all these YAML files together in a templates folder. To make this chart reusable, we have the ability to inject values as parameters. So I can deploy this chart and inject a name that I can use in my deployment, for example, app1. I can then reuse this chart and deploy it somewhere else with a different name like app2. So now once we have this chart, we can effectively reuse the YAML files by injecting parameters into it. This gives us greater flexibility as we can reuse these charts among many applications and microservices. But injecting all these parameters into our chart over the command line can make the command line very long, and we don't necessarily want to change everything inside of the template over the command line. Now, injecting these parameters over the command line is one way of doing things, but Helm also allows us to pass the values as a file. So we can place all the values we want to inject in a file, and we can call that file app1. We can also place values in another file and call that app2. So when we deploy our chart, we can simply supply the values for app1 or app2, depending what we want to deploy. Helm will inject the values into the chart and render the final YAML for either app1 or 2. These files are called values files. Injecting a values file to our chart makes our chart generic. So if you take a look at my GitHub repo, I have a Kubernetes folder, and in that folder I have a Helm folder with a README, and this README shows the introduction to Helm with all the steps I'm going to be showing you guys today. So be sure to check out the link to the source code down below so you can follow along. So the first thing we're going to need is a Kubernetes cluster. Now to create a Kubernetes cluster, I'd like to use a utility called Kind. This allows me to create disposable Kubernetes clusters that I can use for testing. So to create a cluster, we're just going to say Kind create cluster. We're going to call it Helm, and we're going to run Kubernetes 1.19.1. So I go ahead and copy this, I paste it to the terminal, and that will go ahead and create a single node Kubernetes cluster within a container. And once that is done, we can see it's gone ahead and created our cluster. I can verify this by saying Cubectl get nodes, and we can see we have our one node Kubernetes cluster up and running, ready to go. So next up, what I'm going to do is create a small lightweight Linux container, and then I'm going to install the Helm command line and take it for a spin. So to run a small container as a test environment, I'm going to say docker run -it, and I'm going to mount in my home directory because that's where my kubeconfig file lives, so I can access my Kubernetes cluster. And then I'm going to mount in my working directory, which is this entire GitHub repo. I'm going to mount it into a folder called /work. I'm going to give it host level networking, and I'm going to run a small Alpine container. So copy this, paste it to the terminal, and we'll get a small container that we can use. Next up, I'm going to install curl so I can download Cubectl and Nano, which is a lightweight text editor. Go ahead and run that. That'll do the install. And now I can install Cubectl by saying curl, and I can fetch the latest version of Cubectl. I can give it execution rights, move it to user local bin. So I go ahead and copy this, paste it to the terminal, and that'll download Cubectl for us. I also set my default Kubernetes editor to Nano, and to test cluster access, I can say Cubectl get nodes, and we can see we can now access our cluster, so we're good to go. So there's a few ways you can go about installing Helm, but the easiest way I find is go over to the GitHub repo and go to their releases page, and then look for the stable version that you want to deploy, and you can scroll down, and when you go to assets, you can see all the binaries to deploy, and the binaries for Windows and Linux are all here. So I'm going to go ahead and download the binary for Linux and extract it. So this is very easy. I just say curl, and I curl the binary I want. You can see Helm also has a get.helm.sh URL, and you can ask any version of Helm that you want. So I go ahead and copy that, and that'll download the binary to my local machine. Once that's downloaded, I can run tar, and I can extract that binary. So I go ahead and extract it. Now I can also say rm, I can remove the zip file because I no longer need it, and I can move the Helm binary to user local bin. And then last but not least, I have to give it execution rights as well, and we're good to go. So now if I type Helm and I press enter, we can see the Helm command line is installed. If you need Helm CLI on Windows, feel free to download the zip file instead, extract it, and put the exe on your path. So now that we have the Helm command line installed, let's see what it takes to create our first Helm chart. Now a Helm chart is basically a unit of deployment. It's made up with a set of YAML files. We can have a chart for a microservice or any software like Redis, MySQL, Prometheus, and more. A chart has a name, it has an information file, and it has a template folder that contains all your YAML. It also has a values file containing the parameters and values we want to inject into the chart, and this can also be the default configuration values. So to create a new chart, the first thing I'm going to do is change directory into the Kubernetes Helm folder, which is currently empty, only containing our README file. So I say cd kubernetes/helm, and inside this Helm directory, let's create a temp folder where I can go ahead and craft our first chart. So I say make directory temp and change directory. So we got this empty temp folder, and to create our first Helm chart, we're going to run helm create, and we're going to pass in the name of our chart. So I say helm create, and I call my chart example-app. You can call your chart anything you'd like. So when I do this, we can see it creates our example app. We can look in our temp folder on the left, and we see it's created our chart in here in its own folder. Now, if you go to the Helm documentation, they have documentation around a chart and what a chart is and what it looks like. If you scroll down, they also have a section on the chart file structure of what makes up a chart. And if we take a look at the left here, we can see a similar folder structure as what they're describing over here. So firstly, we have this empty folder called charts. And that folder allows us to embed more charts that this chart may depend on. So if you want to nest charts, that allows you to do so. Then we have a templates directory inside of the chart folder, which is basically all the YAML you would like to bundle up to form a chart. And this can be your existing microservice YAML that you have currently. It can also be YAML that you've downloaded off the internet. You can craft your own chart by adding the YAML inside the templates folder. And then we have the chart.yaml. And if you look to the side here, this is the YAML file containing containing information about our chart. So things like chart name, version number, description, and information that tells us what the chart is meant to do. And then we have values.yaml. This is basically the default configuration values for this chart. So the values file is where we can inject parameters. We can basically store stuff like overriding the image tag, we can add labels, and we can override the existing chart to make our chart generic. Now the values file that you see here would be the default configuration, but it allows us to create multiple values files, so you can have a values file per microservice or application. So you could have like values.dev.yaml, values.prod.yaml. It's entirely up to you. So once you've created your first chart with the Helm create command, feel free to browse and explore the templates folder to see what examples there are. Helm deploys a default application in the templates directory with a couple of examples of what you can do. So to convert this into a Helm chart that we can actually use, let's go ahead and clean up the stuff that we don't need. So the charts folder is empty, so that's okay. In the templates folder, I'm going to go ahead and delete the test directory. I'm going to delete everything in this folder except for the helpers template file. So I go ahead and clean that templates folder up. So if we take a look at the chart.yaml, we have the name of the chart, a description, we have the type as application, we can give it a version, and we can put version of the application that we want to deploy as well. So our chart can have a version number as well as the underlying application. If you're deploying something like Redis or something, you can give the right version down here. And if we take a look at the values, it comes pre-filled with some existing values. So what I'm going to do is I'm just going to Control A, select everything, and I'm going to clean this file up so we can use it. So just to recap, I said Helm created a basic chart, deleted everything I don't need. So we have an empty subcharts folder. We have a templates folder with just a helper template inside here. We have Helm ignore. We have chart.yaml and values.yaml. Now converting a pre-existing application into a Helm chart is pretty straightforward. Now that we have an empty chart, all we need to do is take our existing YAML and copy paste it into this templates directory, and we can use it as is. So we simply have to take our existing YAML that we have, and this can be your existing YAML for your applications or microservices, and copy it into the templates directory of the chart. So I have examples here in my documentation. I'm going to go over to the Kubernetes folder. I have a deployments folder with a deployment.yaml. I'm simply going to right click this guy, I'm going to copy it, and I'm going to copy him to my templates directory. So now I have my deployment.yaml inside of the templates folder. I also know my application needs a secret and a config map, so I'm going to go to config maps, take the config map.yaml, copy that, go to the templates directory and paste it there. I'm going to go to the secrets, take the secret.yaml, copy that, go to the templates directory, paste that in as well. And finally, I'm going to do the same thing with services. I'm going to copy the services YAML, go to the templates folder and paste it there. So now I have a Helm chart with a deployment, a config map, a secret, and a service. So what makes it really easy to start off with is we don't need to change any of our YAML. We can simply lift and shift it into a templates directory and create our first chart. So once you've created your first chart, the first thing you'd want to do is test whether it renders correctly. So to do that, we can simply run the Helm template command, and that command takes in a name of a chart and the chart directory as well. So if I say ls, we can see we have our chart directory here. So I can say Helm template, the name of my chart, which is called example app, and the name of the chart folder, which is also called example app. I can copy paste this to the terminal, and we can see Helm generates all the YAML. So we can see it's created a secret YAML, it's created a config map YAML, created our service YAML, as well as our deployment YAML. So the Helm template command is a really powerful command that allows us to test our template by spitting out the raw Kubernetes YAML, so we can make sure it's okay. If there's anything wrong with the YAML file, the Helm template command would render an error. So now that we have our very first basic Helm chart, let's see what Helm allows us to do with it. So to go ahead and install our chart, we can simply say Helm Install, and then we pass in the name of our chart and the folder where the chart is located. So if I run that command, Helm will go ahead and install everything that's part of that chart into our Kubernetes cluster. We can see here that it deployed to the default namespace. This is the revision number and the date of the deployment. I can then go ahead and list the releases. So every time you deploy a Helm chart, Helm will create a release where it tracks the revision. So I say Helm list, and we can see we have our name of our Helm chart, the namespace we deployed it to, the revision number, the updated date, and the status. We can also see things like the app version and the chart name and version. And we can get a full list of everything that's been deployed. So if I say Cubectl get all, we can see we have 2 example deployment applications. We have our Kubernetes service, we have our deployment, and I can say Cubectl get CM to get the config map. We can see that exists, and we can make sure our secret is deployed by saying Cubectl get secret, and we can see it's been deployed and created. So at the moment our Helm chart is very basic and it's not really reusable since we're not injecting any values. And if you have a CI/CD system, you might want to inject like a build number and rotate the Docker image tag. And you'll remember earlier that I spoke about the concept of a values file as well as parameters. So the values file and the parameter injection allows us to inject values into our chart, making it reusable. So let's inject the name of the Docker image and the tag into our YAML file. With this concept, you can structure your YAML file any way you like. So one example is we can simply take the deployment image and tag and add it to our values file and then inject that into our chart. So in our chart, I have the Kubernetes folder in the Helm, in this temp directory, we have our Helm chart, and inside there we have the values.yaml, which is currently empty. So let's go ahead and add some fields to this values file. So something that I can do is I can say deployment, and under the deployment I can have an image with my image name as well as a tag with the tag of the image. So the values file is where I can put anything that I want to override in the chart. And to inject that into the chart, what I need to do is go over to my deployment.yaml and add this style of syntax. So you can see there's a templating syntax that we can use. So I go over to my chart in the templates folder, I have a deployment.yaml. And when I open this deployment.yaml, we can look for the values that we want to replace. In this case, I want to replace the image that I've hard coded here. So one thing we want to replace is the actual image name. So this image name we want to replace. So what I can do is grab this portion over here, and that will replace the image name. So we use the syntax .values.deployment.image, and then we can replace the tag like so. So we can replace this 1.0.4 with the actual values syntax. So this is the syntax that Helm uses, which is basically Go templating. So now instead of hard coding the image name and tag in our chart, we now allow the user to override it at the time of deployment. So to show you how to inject your custom values file, we can basically say Helm upgrade. So let's upgrade our release. So I say Helm upgrade, the name of the chart, as well as the folder of the chart. So this is exactly the same as the Helm install command. And then I pass the values using the -- values flag, and I pass the path of the values file. So when I run this in the terminal, Helm will go and upgrade our release. So we can see now we have our name of our release, the deployment date, the namespace, the status, and the revision, which is now 2. And to see the revision, I can say Helm list, and we can see the revision over here. If you don't want to use a values file and you simply want to override 1 or 2 values over the command line, you can also use the set flag. So you can say Helm upgrade, the name of the chart location, and you can say -- set. And here you can see I've set deployment.tag to 1.0.4. That basically allows me to set this value automatically when I pass it in over the command line instead of using a values file. So that's another option. So you can use this templating engine and notations to replace pretty much anything you like, making your chart more generic. For example, you can create a chart to allow your teams to deploy their microservices and share the same chart among many services. If you create like some form of generic microservice chart, or if you want to deploy more complex software like Redis or RabbitMQ clusters, you may want to create a gold stamp vetted Helm chart for your organization that you can use to roll out this type of software. So let's go ahead and make our Helm chart even more generic. So one thing we can do to make our chart a little bit more generic and reusable is to inject a custom name for all the objects in the YAML file. So as an example here, we can go through all these objects and we can insert values.name as the name of each of the objects. This will make sure that none of the objects clash, and every time we want to deploy the chart, we can supply a specific values file for that application. So to show you an example, I'm going to go to my values file and I'm going to add a name to this values file. So you can see I have name, and this is the name of my application that I want to deploy. So this could be the name of the microservice. And then what I can do is I can go to my deployment.yaml and I can go ahead and replace all the names and replace it. So firstly, I don't want to call it example deploy. I'll do something like this. So I say values.name as the name of the deployment, and then I'll go ahead and replace all of these names. So I'll hover over that, I'll say find and replace it with that. So we'll replace the label, we'll replace the selector, we'll replace the label of that guy, we'll replace the container name, and that's done. And we'll do the same for secrets and config. So let's go to the config map, replace this name with a more generic name, replace this name with our values, go over to secret, we'll do the same thing over there, we'll go to service and we'll replace the name as well with this guy, and we'll change the labels as well as the selector. Go ahead and save. So now that our Helm chart is super generic, we can deploy multiple instances using this chart. So I can go to my values file, I can create a copy of it, and I can rename this copy to example app-2.values.yaml. And in this YAML, I can give this guy a different name. So I can create another service with another Docker image name and tag and call this one example app2. And then to reuse that chart and deploy example app2 of our application, I can say Helm Install example app2 and point it to that same chart. And I can apply the values file of example app2.yaml. And when I run that, we can see that we've now created a new release called example app2 and it's on revision 1. We can say Helm list and we should see 2 applications deployed side by side. So these 2 applications are deployed with the same chart. If I do kubectl git deploy, we can see we have 2 applications deployed. And the same thing with service. I have 2 services deployed. I also have now example app2 as a secret, and I have the config map for example app2. So you can see this makes our chart super generic. We can reuse it across multiple applications. I can take this even further by creating another copy of this YAML file, and this time calling it example app3. I can change the value to 3, and then I can say Helm install example app3 using the example app chart, pass in the values file for example app3, and we can see we now have a new release for that guy. And if I say Helm list, we can see we now have example app1, 2, and 3. So as you can see, Helm has really powerful template generation capability, and another feature to showcase the power of this capability is to automatically roll out new pods when a config map changes. By default in Kubernetes, when a config map changes, pods are not automatically restarted, and some applications might need a restart to pick up the new config files. So when a config map changes with a new config file value, the pods in Kubernetes won't automatically restart to pick up this config, and we can use Helm's powerful template generation capability to overcome this issue, and it allows us to forcefully roll new pods when a config map changes. Now when we change a config map, what we can do with the template generation is we can trigger a change on the deployment that'll tell Kubernetes to forcefully roll out new pods, and they'll pick up the new config map. So to make Kubernetes roll out new pods, we have to trigger a change on the deployment, and to do so we need to detect a change on a config map. So what we can do, if we take a look at this example, we can update an annotation on our deployment object, and part of this we can basically add an annotation that creates a checksum value of the config map.yaml. So whenever the config map changes, the encoding of this statement will be different. So you can see we basically use an include function and we print the contents of the script and we pipe it to a checksum function. So every time the config map changes, this checksum function result will be different. So it will basically create a unique annotation on this deployment which will forcefully trigger a change in Kubernetes. So to do this change, I can go over to my templates folder, go to my deployment.yaml, and we go to the deployment spec template metadata, and we add an annotations field to the metadata, and under annotations we add this guy. So we add the checksum config and we do this function. So to keep my values file consistent with the others, I'm just going to rename it, and I'm just going to call it example app-1.values. So to trigger that change, we're going to say Helm upgrade, the name of our application, name of the chart file. We're going to pass in our values file for app1, and that'll go ahead and roll a new deployment. And when I do kubectl get pods really quickly, we can see the old pods are now terminating and new pods have started up. Now for more complex style template generation, Helm also allows us to do control flows. So we can have if and else statements to generate more complex YAML based on the values we pass in. And it also allows us to set defaults. So let's say we want to enforce things like CPU and memory requests and limits. We can do things like allow the user to set their own resource requests and limits, or fall back to defaults if they're not supplied. Or we can allow users to simply set requests but not limits. That's entirely up to us. To allow this capability, we can use if and else statements in Helm, which are really straightforward. So to demonstrate Helm chart's control flows, I've got this basic resource requests and limits using if statements. So you can see I have a bunch of if and else statements here to demonstrate control flows in Helm. And you can use this with anything. In this example, let's see what I've done. So in this example, we want to set some resource requests and limits if the user has supplied them, otherwise default them. So you can see what I do is I say if values.deployment contains resources, start generating the resource block. If the values.deployment.resource.request is supplied, start generating the request block. And then I can add values for memory and CPU. And what I can do is if the user has supplied deployment resource request memory, then use that value. Otherwise default it to 50 megabytes. And also ensure that there's quotes around it, so we can use the quote function to do so. The same thing for CPU. I can say if the CPU request values have been supplied, I can use them, otherwise default to 10 millicores. And then I can also enforce quotes around that too. If the user has not supplied any request blocks, we can have an else statement generating a request block for them. So this would generate just a basic request for memory and CPU. And then in here I show you the exact same example, but this time using resource limits. So if the user supplies limits for memory and CPU, we go ahead and use them, otherwise we default and we ensure there's quotes around them. If the user hasn't supplied any blocks for this, we go ahead and we set the entire block. If the user has completely left out the resources block, we can go ahead and generate a default block for them. So this allows the user granular capability to override requests and maybe not limits, or override everything or leave it blank. And this demonstrates how you can use if-else statements within your Helm chart. So to use this, I can go ahead and grab this YAML over here, and I can go to my deployment.yaml, and I can replace this resource request and limits block that I have here with the actual values that I paste in. Now be very careful with YAML. When you paste, you can see my text editor here has injected spaces automatically. So you got to be very aware of line indentations when working with YAML, which is the pain of YAML files. If I go ahead and hover over that, I just need to make sure that I move it so the indentation is correct. I then go ahead and roll out this change saying Helm upgrade, name of the application and chart file, and then I pass in the values for application1.values. And when I do this, we can see revision 6 has now been rolled out. And we can see our old application is terminating and the new one has started up. And if I do Cubectl get deploy for that deployment that I've just created, we can see our resource requests and limits have already been set. And this is because I did not supply it in my values file, so the Helm template generation has created the defaults for us. So that's the basic of Helm templating, but be sure to check out the Helm documentation for more advanced template functions and pipelines. So hopefully this was a useful and subtle introduction to Helm and Helm charts. If you're looking for an alternative to Helm that's maybe a little bit less complex, be sure to check out my link below to my Customize video. Customize is an alternative to Helm which allows you to do very similar things. And let me know in the comments below what sort of videos and topics you'd like me to cover in the future. And remember to like and subscribe and hit the bell. And also check out the link below in the description to my community page. And if you want to support the channel even further, be sure to click the join button down below and become a member. And as always, thanks for watching, and until next time, peace.